Kaleigh, and this year I decided to study genetics. My quote for the year is, "At bottom, every man knows well enough that he is a unique being, only once on this earth, and by no extraordinary chance will such a marvelously picturesque piece of diversity in unity as he is ever be put together a second time." So pretty much that means that every single person on this earth is different, and that yet we're all unified through our DNA. And I think that's really interesting that every single person is unique. So genetics is the study of heredity and variation of inherited characteristics, and it's made up of chromosomes, which are found in the cells. And inside your chromosomes are genes and DNA. The DNA is wrapped around the chromosomes, which are like in an X shape, and inside the DNA is your genes. Genotype is like the actual scientific genes, what shows up there, and the phenotype is like what you see on the person themselves. So like the phenotype would be like having blonde hair. And genetics is used in diagnosis for the most part. Like some people will go to like 5 or 6 different doctors and never get a diagnosis until they finally see a geneticist, and then they can get information on what's really wrong. And with some diseases, if you can detect them early enough, you can get a treatment, but if they're not found until too late, it can be fatal. This includes like cancer and stuff. And it's also used in IVF, which is in vitro fertilization, which people use in pregnancies. So some people who may be carrying a disease would see a genetic counselor, and that way they could see if they're going to pass that down to their child. And if they think they are, they can use in vitro and be able to prevent that. Counseling goes along with in vitro, really. You'll see a genetic counselor to be able to predict your chances of having a child with whatever disease you carry. The research I've done so far this year, these are pretty much the research assessments I've done. Predicting diseases was the first one. I researched how you can just get a simple blood test, and then they can be able to tell you what diseases you'll come down with later in life, which I thought was really interesting. Like they can detect whether or not you'll have breast cancer just by looking at certain variants in your genes. Designer babies. This article was kind of disturbing. Like, people can, through IVF, pick the hair color of their child, their gender, their eye color. There's actually a clinic here in Frisco that does it. And I think it's kind of like playing God. So that's where the ethics part of genetics comes in. Huntington's disease, I learned about some of this in one of my interviews, so I decided to research more about it. It's a fairly simple disease that affects the nervous system, and it causes seizures and brain damage and eventually death. So it's a really horrible disease that a lot of people, not a lot of people, but some people have, and it's passed down to their children. So my mentor told me this example that I want to share with you that I found really interesting. So say a mother thinks she carries Huntington's disease, but she's not sure. So she wants to get IVF to make sure that her child doesn't have it. But she tells the doctor that if her embryos do carry it, to not tell her because she doesn't want to know. But she tells her doctor that she wants the healthy embryos implanted first. So if the healthy embryos don't succeed, then the doctor has to implant the babies that carry Huntington's disease, but they can't tell the mother because the mother doesn't want to know. So now the doctor has to implant unhealthy babies into the mother without the mother even knowing that she and her child are both now going to have the disease. So that's when ethics plays a huge role in genetics, which I've been researching a lot more about because I think it's really interesting. And breast cancer detection, I've already talked about this to a point, but right now people use mammograms to detect breast cancer, but they're looking more towards genetic sequencing. Like, for example, with breast cancer detection, you can get a false positive, meaning they'll tell you that you may have breast cancer, even though you don't. This has happened to my mom before. And so it's a really scary time because you think you could have cancer, and then you go in for extra testing, and you find out that it was not even true. So with genetic sequencing, it's a lot more reliable. There's less false positives, and there's also less false negatives, meaning they miss it completely. And through that, they can also detect your likelihood of getting it later. Prenatal sequencing is testing your child before they're even born, really, which is technically illegal right now, but some people are still doing it anyway because certain diseases won't come down, you won't come down with them till later in life, and they're always fatal, like Huntington's disease. So you can test your child for this, but there's no cure and there's no treatment. So now your child has to live with that information for the rest of their life, which isn't always something people want. And then gene therapy, I learned about this in another one of my interviews. It's where people will implant a healthy gene into a virus and then implant the virus in the person who's sick. And the goal is that the virus will attack the unhealthy genes and try and change them, but it hasn't yet been successful. Jesse Gelsinger was one of the first people to ever be tested for this, and he had a rare disease, but he was living okay with it, and so he signed up for this treatment, and it ended up killing him. So he was only 18. So they haven't really tried a lot of it since, but there's been some more progress. They can now cure blindness with this, like to a point. So there's still going to be more research. I've had 5 interviews. The first one was with Dr. Angela Shirley through UT Southwestern. She was involved in both clinical genetics and pediatrics. So this is something I found interesting. Most geneticists either pair genetics with like pediatrics or gynecology or internal medicine. So most people don't just do genetics. They usually specialize in something else as well. She worked with the Texas Department of State Health Services in birth defects epidemiology, which means she tested a lot of drugs that people will use during pregnancy and how they can create birth defects. She was a previous mentor with a student with Centennial, so that kind of put me at ease because I knew that she already understood the program, so I didn't have to worry about like explaining what my goals were and stuff. It was a really successful interview since it was only my first one, and I was pretty nervous, but I thought I did pretty well. My second interview was with Dr. Ralph Deberdinis. He was also through UT Southwestern, and he specialized in metabolic disorders, meaning like disorders that affect the metabolism and in different genes, which those are usually really rare. He usually works with children who have a disease that's only found like 1 in 100,000 children. So that means everything he works with is very varied, and he doesn't ever get bored. So I thought that was good. He's also the head of the lab at UT Southwestern, which I didn't realize going in. So he's really high up there. He's also the assistant professor of genetics and pediatrics at UT Southwestern. So he's used to teaching college students already. And he's in an administrative position. So okay. So he mostly writes a lot of papers and stuff. He told me that it takes $1 million a year just to run the lab. So as much as that interview was very interesting, I learned that I wouldn't want to work in an administrative position, even if it does mean more money, because I want to help patients and do research. I wouldn't want to just write papers all day. My third interview was with Dr. Helen Hobbs. She was also at UT Southwestern, and she also does rotations at Parkland. She does a lot of lab work, which was a different side to me. I'd never learned about the lab side of genetics. I've been focusing on the clinical side. And she also writes a lot of papers and research for articles and magazines. She identifies genetic variations that counter susceptibility to fatty liver disease. That's one of her newest discoveries in the lab. One of the most interesting things about this interview was how diverse everyone that works there is. they had a huge map on the wall, and they had people from like Australia, I think there was one from Thailand and Holland, and they were from all over the world. And she gave me a tour of the lab, so I got to see like everything that goes on every day. It was really surprising to me how cluttered it was. Like I never expected that, but there was stuff like everywhere, and I could see the things they were like looking at DNA just like we used to do in like freshman year biology. They like actually use electrophoresis. It still happens. So that was really cool to be able to connect what I've learned so far to the real world. And my fourth interview was with Dr. Louis Amanya. He went to school at Baylor and currently works at UT Southwestern. He was also Colombian, so he went to school in Colombia and along with medical school, so he had a really thick accent, which I got used to as I went, so it wasn't that big a deal, but he had a lot of different experiences that no one else I'd talked to had. He also works in pediatrics and genetics, so he sees a lot of children in the clinic. He also specializes in metabolic disorders that are really rare, and he has researched more in gene therapy, which is why I originally did that research assessment on it, because I thought it was really cool that they could implant viruses like that and like pretty much tell them what to do. And my last interview was with Dr. Mary Lynn. She was formerly an OBGYN, and right now she's in a fellowship at UT Southwestern, so she's training to be a geneticist. She attended the University of Alabama, and she works at Children's Medical Center. She was the one that told me the example about Huntington's disease, so I was inspired to learn more about that. She also works with a lot of children and babies. I originally thought I wanted to be a neonatologist who works with newborns, so it was really interesting that she still gets that aspect of genetics, but can still learn about like heredity and stuff. And I ended up choosing Dr. Lynn as my mentor because there's an emphasis on prenatal care, and she's still rotating between the lab and the clinic because she's still in training. So I could get to see both sides of genetics versus just the lab or just the clinic. She was really good at explaining things because I think she's 29, so I could connect with her better. And since she's still learning, she has the firsthand experience of the people are still explaining things to her, so she was good at explaining things to me. And my original work, I'm probably going to do newborn screening, which that's the first test a child will receive right after they're born. A lot of people call it the heel stick test. In Texas, we test for 39 diseases, including hearing loss, congenital heart disease, cystic fibrosis, PKU, and sickle cell disease. Those are just some of the ones that are common that a lot of people have heard of. Other diseases are still a problem and are really common, like ADHD, dyslexia, autism, asthma, and acid reflux disease. So I want to learn more about how these diseases are hereditary, and if we can test for them at an earlier age to see if these children have them. Like, for example, my mom's a first grade teacher, and she has kids that are dyslexic or ADHD, and they struggle a lot in school because they don't have the treatment they need and they've not been diagnosed. So I think if we could help these children from birth, maybe we would be able to circumvent some of the problems that they're having in elementary school so they don't get behind in their schooling. And I also want to be able to educate parents on what diseases their children are being tested for in the first place, because currently when your child has the newborn screening, you don't really even know what they're being tested for unless the results are positive. So I think it would be good for parents to know what their children are being tested for and have the option of additional testing. And here's a video about why this is important.
After your baby is born, he gets his first test to check his health. This is called a newborn screening test. In this video, we'll hear from Lillian Osowski, a mother and advocate for newborn screening, on why newborn screening is so important to the health of every baby.
When you find out that something's wrong with your child, you go through those stages that people do when they find out they have a loss. Because the healthy baby that you thought you were going to have, and all those dreams are all going to have to be changed. You just ask why. Why me? And why my son? And you don't want them to have anything. I just want to have a baby, and you think that that's all going to be okay. And then comes the hospitals and the medicines and the therapies and the money that you spend. And it's one of the hardest times of my life. In 2005, I went with the March Times to Boston and testified before the House Public Health Committee and told the story about Connor and how he was not screened for the disorder that we came to find out that he had, and told them a little bit about what it was like for the time that between his birth and when we were finally diagnosed, and talked about how hard it is thinking about what you might be like if he had been diagnosed, and hopefully how well the other children will be that will be caught. And thankfully, they passed along. And in January of 2007, every baby in the state of Texas was tested for 27 disorders. I got a phone call in May of that year from a lady in Dallas, and she wanted to call me to thank me. Her daughter, Sarah, she was born. She was diagnosed with the same disorder as my son. So it's a wonderful thing to think that even though my son may not have benefited from being diagnosed with birth, at least she will. So it's just wonderful to hear that one of them was caught and that she's going to be okay because of that. So very proud that I went to call.
To learn more about newborn screening or how to get involved, visit marchofdimes.com.
So that's pretty much why newborn screening is important. Currently they test for 39 diseases, so that's a big step up from where it was back then. Also, newborn screening is now mandatory unless it goes against your religion. So everyone receives this test, and it's also free. So parents who don't have the money to support their children in their medical care will still be able to at least receive this test. So this year through ISM, I hope to gain hands-on experience as well as to help people who are suffering from serious diseases, and also learn more about my college major and what I want to do after college and gain important professional skills through ISM. That's it. Thank you.